Okay, we're told our vessel's trimmed 0.32 by the stern and heeled 8 degrees to starboard. We're given our displacement in kg, and we're told we've got tunnel side tanks, port and starboard, are full of fuel oil with centroids 4.3 each side. And number 3 double bottom tanks, port and starboard, are empty and have centroids 4.8 each side. Using the data booklet, calculate the amount of fuel oil will transfer from the tunnel side to number 3 double bottom to get the vessel to even keel. In these problems we don't take account of any free service moments, doesn't come into it with these problems, but I've done a sketch here to see if you can visualise what's happening. So here are the tunnel side tanks, 4.3 centroids either side. We're going to transfer to number 3 double bottom tanks to get the vessel to even keel. Okay, so what we'll do, we'll transfer and we'll take an equal amount out of these two tanks and then put the equal amount in these two. Therefore we're not going to make the list any worse because we're simply getting rid of the trim, getting the vessel to even keel, and the distance apart is not going to change to create moments. So let's look at the first part of the problem. So we go in the tables at 10,600 displacement to get our MCTC and KM. So we just need the MCTC at the moment. We know our change of trim is 0.32, so that has to be 32 centimetres. I'll just show you the formulas here. So change of trim on your formula sheet is trimming moment over MCTC. We know the change of trim that we have to do. We've got the MCTC. And we know we can also write change of trim as weight times distance over MCTC, because of course a moment is a weight times a distance. The distance will be the distance longitudinally between the two tanks. And when we go in the data booklet, we see that number 3 double bottom tanks are 57.87 longitudinally LCG, and the tunnel side tanks are 21.08. So what we're going to do is move this weight longitudinally from 21.08 to 57.87. So that's going to be the D in this formula. So we know D, the distance, we know change of trim, and we know MCTC, therefore we can find how much weight we would move. Sometimes D is written as S, it doesn't really matter shift or distance. So we've written here, and on my answer I've written it as S there, so I use different ones. So the trimming moments, I've transposed the formula and I've ended up with a weight of 140 tons. Okay, and I've just clarified there, S is the distance the fuel is moved transversely, and there's the distance, one minus the other. So we've taken 140 tons, and what we've done, we've put 70 tons in each of number 3 tanks. So now we've moved 140, that's how much we've moved, and we've simply put 70 in each tank. Then it asks us for the weight of fuel oil to transfer to get us upright, and with a list of 8 degrees. So now we need to get upright. Well, we know the formula for list, we know the angle of list, we know the displacement of the vessel, and we know our GM because of course we can get the KM as we did at the beginning. So there's KM and KG. So our listing moments we can work out are 477, and we know that moments are a weight times a distance, so we can say that 477 equals weight times S, or weight times D. S is the distance transferred transversely, and when we look at our sketch we're going to transfer from this centre to that centre. So it's important that you divide the listing moments by 4.8 twice. Okay, you must use twice 4.8. So we're going to move 50 tons, and we're going to transfer from starboard to port. So what we did initially was put 70 in each one, so we're going to take 50 and place it here. Therefore number 3 port will have 120 and number 3 starboard will have 20. So be careful with this particular area here that you make sure that you use the 4.8 twice to work out the transfer from one side to the other.